Hi, welcome to 10.5, Series and Circuits. Now, if you remember from last time, we looked at a torch circuit, and in that one, there was a switch, a battery, and a bulb, all on the same kind of circuit, right? So this is what's called a series circuit. Now, imagine we had multiple bulbs connected to that circuit, all right? Imagine this was a it was basically the same thing. So we had a power source maybe down here, and then we had wires, and all these different lights are all connected on the same circuit. What that would mean is, if we even had one bulb go out, alright, that would break the circuit, and then all the other bulbs would go out. And that's what happens in a series circuit. Alright, so then what we want to do instead is we want to do what's called a parallel circuit. Alright, so let's have a look at those. In a parallel circuit, you don't have the battery connecting, in one solid line. What you have is the being basically like two little circuits here. So even if this bulb goes out, the power from the battery can still work its way to this top bulb. All right, and that's what's called being in parallel. So these two bulbs can work independently. If this bulb goes out, doesn't mean that this bulb blows. Okay, so there are a couple of factors that determine how quickly energy flows through a bulb. The first is the amount of energy each electron that's flowing through the bulb has, so the amount of energy that's in the electrons, and the voltage is what the measure of this. All right, and the second factor is the number of electrons that pass through the bulb. So that's basically the current. So the voltage is the amount of energy in the electrons, and the current is the number of electrons that flow through. All right. So if you had identical bulbs in a series circuit, they would have the same brightness because they would share the voltage equally, and all the globes would have the same electric current. And just the same in a parallel circuit, it's a very similar thing. So they have the same brightness because they all have the same voltage, again, because the electrons are still the same amount of energy going into them, and they share the electric current equally. However, in your house, you probably noticed that you have bulbs of different brightnesses, and basically what this is that each individual bulb resists a certain amount of electrons or whatever else passing through it. So whether it's fluorescent tubes or a standard bulb or the thickness of the filament, I mean, it would make a difference as to the number of electrons that can easily pass through it, and that would determine the brightness of those bulbs. Alright, I'm going to leave you with a question. So, the lights in this diagram here, they are connected in parallel. I want you to answer why, and I want you to tell me in class why the lights in this office, in this picture, are connected in parallel. And then once you're done with that, it's a very easy one today. You've got some blue words to copy out into Quizlet, and then you've got questions 1 and question 2, and then we'll have a talk about the rest in class. Alright, have a good day, and I'll see you in class.